So I'm William. I'm an HAProxy software engineer, and I'm one of the commander of the HAProxy TLS stack. And today I'm going to talk about TLS on HAProxy 3.2. But first, I'm going to start with a little bit of history, the story of TLS within HAProxy. So TLS was not mandatory in 2010, we'll say. There was no native TLS in HAProxy. Us developers, we did not know much about TLS at this time. Libraries were complex. It was difficult to understand OpenSSL. It's still difficult. Most TLS implementations were using fork and thread models. HAProxy is an event driver model, so we didn't know how to use SSL in HAProxy. We thought that cryptographic operation would be too expensive for non-blocking, and we thought that we will never implement TLS natively. But there were still users for TLS. These users were using Stunnel. So Stunnel is a well-known tunneling program. It's basically a TLS front-end that you put in front of your TCP service. It basically crypts everything, and it was available in forks, thread, and uContext model. At the time, we were using the uContext model, which is kind of coroutines. But the architecture was really different from HAProxy. So this was a typical deployment. You will have one Stunnel on the same machine of HAProxy, or even you could have multiple Stunnel in order to scale. But we had to tweak a few things. Stunnel was kind of difficult to use because HAProxy wouldn't be able to see the client IP. Basically, in the log, you will see only the IP of Stunnel, which was localhost. So it wasn't really meaningful in the log. So we created the proxy protocol at this time, which is basically a small header at the beginning of the connection, which contains the client on the port, the source port. And there was also the problem of TLS assumption. So at this time, it was mostly TLS 1.0, TLS 1.1, and it was mostly stateful resumption. So for stateful resumption, you need a cache. And if you have multiple Stunnel processes, you need to share this cache. So we implemented a shared cache, but scalability was still limited. But at this time, this was enough. However, a few years later began the TLS everywhere era. Maybe you remember the green address bar in Firefox and Chrome. So lots more people wanted to have TLS on their servers, but we needed something more performant than Stunnel. There wasn't much alternative at the time, but the Stud project appeared. So Stud is an event-driven project. It's kind of like a HAProxy. There wasn't any fork and thread. So we started to work with it, and we contributed a little bit. We added the same features that we added in Stunnel. So basically the proxy protocol and the shared session cache. The project still exists today. It became Itch, which is maintained by Varnish Software. So the deployment is pretty much the same, but you will be able to use only one process because it was more performant and more scalable. However, Stud was functionally limited. It was still a separated process in front of HAProxy. So that was still costing a lot of memory on the CPU. So we abandoned the idea of using a stud because, in fact, we learned a lot by contributing to stud. The architecture was pretty much the same as HAProxy, so that showed us that it was possible to make it work within HAProxy. So we never used Stud. In fact, it was only a proof of concept. And we instead started to develop our own TLS stack. It took a lot of time. It started in 2010 and was 4 years on development, but it was a fairly complete stack. So as Baptiste mentioned this morning, there is this website, is TLS fast yet? And at this time, we were one of the best implementation of TLS. We still are, but this is we are still the best, not the best, but one of the best. So it simplifies everything. You would only have one HAProxy on no other process. So once we had our complete TLS stack, we need to improve the configuration and the management. So we had some users with hundreds of thousands certificates. It could be difficult for those others because HAProxy could take a lot of time to load. It could take, for example, 5 or 10 minutes. And if you reload, you will have the same 5 or 10 minutes. And if you want to add one certificate, just remove one certificate, you don't want to do that. So we implemented a few features to make it easier. We first implemented the internal certificate cache, which load the certificate in memory only once. So basically, if you look at this configuration, you will have one certificate, the same certificate on all those lines. So if you don't have a cache, you will load the certificate on the disk each time. So the cache allows you to reduce the loading time because it will be loaded only once. We also have the CRT list. It was implemented in HAProxy 1.5. It's a system that allows you to list a lot of certificates in a file. So if you have thousands of certificates, you just put the name of the certificate in the file. You could also use TLS option per certificate. So for example, in this configuration, you will have one certificate which will be configured for TLS via 1.3 and another one with 1.2, and you could configure Cypher and a lot of other things. And at the end of the line, you could put the filters which allow you to use another domain than the one which is inside your certificate. So for example, if your certificate is provided by your customer, you probably want to check if it's a right domain. So you just have to put the domain of the customer on the line. But CRTLists were great, but it was still complicated because you still needed to reload if you want to add one line or remove a certificate. So we wanted something more modern, more dynamic, and we introduced operation over the runtime API. So in this example, we are creating a new certificate, which is called Site 1. We are filling it from the disk, committing it. So this is basically a small transaction. And then we are adding it in an existing CRT list. You can also put the configuration like the one that's in the file. There is also a lot of other stuff, like you could dump from the CLI to an existing file at runtime. So it was still difficult to organize certificates. Previous version of HAProxy needed the key and the certificate in the same PAM file. It was not convenient if you wanted to separate the permission of the file or just put the certificate and the keys in different directories. So the CRT store is a way to configure the storage. If you look at this example, you will have the Sit1 CRT with its key configure. You also have an option like the OCSP updates and other options related to storage. You can also use aliases. So basically, the S2 alias allow you to use S2 in the configuration instead of the whole name of the certificate. So you can kind of split the certificate per feature, per customer. So, for example, you have the Web1 namespace there, but you could create a namespace per customer, for example. Yeah. CRT stores are convenient to configure the storage. However, the only way to configure a TLS option per certificate was the CRT list. It was not convenient when you are dealing with hundreds of front ends because you will need to create one CRT list file per front end. And if you only want to have 3 or 4 certificates, it's not really great. So we introduced the new SSL fuse keyword in HAProxy 3.2. It's basically a CRT list inline in your front-end configuration. You don't have any byte-line limitation, so you can just put all your TLS option on the SSL fuse line. It's also more dynamic because you can use all the CRT list operation on the stat socket. And in this example, it's an elegant way to deduplicate your configuration. So if you want to do TCP for HTTP 1 and 2 and QUIC for HTTP or HTTP 3, you will need, with the standard way of doing the configuration, you will need to put your certificate twice. So once on the first line and the same certificate on the other line. So there you just have to put all your certificates on each SSL fuse line, and they will apply on every bind line in the front end. So in HAProxy, we are aiming for performance, security, and modern features. So we are providing a complete and modern TLS stack. So recently we had the QUIC feature, the QUIC protocol on front-end side. It's implemented with every library that we support. With OpenSSL 3.0, it was kind of difficult because there wasn't any QUIC API. So we had to hack a bit to make it work. But with new release OpenSSL 3.5, there is a full support for QUIC because in previous version we didn't add zero RTT because of this hack. With HAProxy 3.2, we implemented the ACME protocol. It's an experimental feature for now. We're going to have a talk about it later in the day. So modern stacks are evolving. HAProxy supports a lot of stuff, but you should update what you are using. Stop using TLS 1.0, stop using SSL 3, I don't know. A lot of algorithms and cipher are evolving. We are now talking about deprecating the standard Diffie-Hellman. No, it's the elliptic curve Diffie-Hellman. People are still using a lot more the elliptic curve DSA instead of the RSA certificate. And maybe stop using stateful resumption because it costs a lot. And stateless resumption is working everywhere in modern stacks. So regarding the libraries that we are supporting, we have OpenSSL 3. So the 3.0 version was a mess. Don't use the 3.0 version. Unfortunately, it's a package everywhere in the distribution, but you should upgrade at least to 3.1 or maybe the latest release, which is 3.51. We supported QUIC TLS. It was just a patch set on top of OpenSSL, but it's becoming something else now. We support WolfSSL as well, which is an efficient library, but it uses a compatibility layer, so we don't have all features with it. And we support AWS-LC, which is for me the best library out there for HAProxy. So you can take a look at this benchmark. This is basically the number from our article, the state of SSL stack. At the bottom, you can see that this is OpenSSL 3.0. And at the top, it's AWS-LC and WolfSSL. In the middle, you have OpenSSL 1.1, which is better than OpenSSL 3.4, 3.5, basically, it's the same. So what's next? The future of HAProxy on SSL. Baptiste talked about it this morning. So we are going to provide packages for the community and also for enterprise using AWS-LC since it's the best choice for security and performance. There is also the Rust TLS library, which is interesting. We made a little proof of concept last year about it. It wasn't working great because of the OpenSSL compatibility layer, but the developers from Rust TLS contacted us and they want to make it work better. QUIC TLS, it's becoming something else. It's not a patch set anymore. It's becoming a new library with its whole new cycle. So they want to fix the problem of OpenSSL. We also want to complete our ACME support. So today it's HTTP 01 on DNS 01 with an external component, but we want to do more. There are also the ETH feature, which is encrypted client hello. the problem that it fixes is that basically the client hello doesn't encrypt the domain that you're asking for. We also want to make progress on key TLS, which is the kernel implementation of TLS, which is very interesting if you want to use cryptographic acceleration from the NIC. And maybe more things. So if you need something about TLS, don't hesitate to ask. So, yeah. Thank you.